In lesson 1.3, we're going to take the structure that we've been building for the last 2 lessons and continue working with it. And then I'm also going to show you one other thing that we're going to incorporate into this lesson. And the reason that we add a new thing is because this is the first time where we see the variables on both sides. So I kind of just gave it away, but what is the difference between this equation and this equation? They both have 2x, x, and 10. They both have a plus and an equals, but the equal sign has been moved, and so it made the x go to the other side. You see, this side has the x's on the same side, so we could easily combine them into 3x. But over here we can't, because in 1.2 we learned that you can only combine variables like that when they're on the same side. So since they're on different sides of the equal sign, we have a different procedure. So the procedure is that when the variables are on different sides of the equal sign, you must move them by adding or subtracting until all variables are on one side and all numbers are on the other. So I'll show you in this example what that really means. So I've got 15 minus 2x equals negative 7x, and you can see that there's an x on the right and there's an x on the left, and so this is our new style. So the procedure that we've built is the same, drop a line down the equal sign. But the new thing that we're going to now start doing is deciding which side we want to bring our variables to and which side we want to bring our numbers to. It doesn't matter, but we're going to now be labeling the sides so we know and our reader knows where we're moving our things. So just for picking a random example, I'm going to keep the numbers on the left, so I'll put an N on the left side for numbers and a V on the right side for variables. So this is where I want anything that's a number to be, and this is where I want anything that's a variable to be. So now you look at the equation and you have to decide who has to move. This is a number, so it's on the correct side. But this is a variable, so it is not on the correct side. It actually has to be on this side because that's where the variables go. So if I have to move this, how do you think I'm going to move it? Do you think I'm going to move it by adding or subtracting? Hopefully you're saying adding because you have subtraction, so the inverse is addition. So let's add 2x to both sides. So I bring down what I have. I have 15 equals negative 7 plus 2 is negative 5. Now before I do anything else, I have to check to see that things are still on the side they belong on. So is everything on this side now a number? Yes. Is everything on this side now a variable? Yes. So nothing has to move, and at this point I can just do my one final last inverse, which in this case would be not addition. You would divide by negative 5 because a number next to a variable is multiplication. So I'm going to divide both sides by negative 5. Hopefully you didn't say addition. If you did, come talk to me and we'll go over some examples. 15 divided by negative 5 is negative 3. Since these examples are a little more complex, we certainly have to check them. So let's do it. I'm going to write the equation exactly how I found it, but instead of x, I'm going to put negative 3. 15 minus 2 times negative 3, notice I'm using the parentheses, equals negative 7 times negative 3. So now, since I'm in the check, I'm not going to do inverses, I'm just going to do order of operations. So the first thing that comes is negative 2 times negative 3. So I'll get 15 minus negative 6, because 2 times negative 3 is negative 6. And then on the right-hand side, I get positive 21 because a negative times a negative is a positive. So I have to check to make sure that I get the same thing on both sides. 15 plus 6 is 21. So that checks. Now, another thing that is tricky about the check is that you don't know what number you're supposed to get on each side. You just hope that it's the same thing. When I plugged in negative 3, I didn't know what number I was supposed to get because there were variables that I needed to calculate on each side. But as long as you end up with the same number, then you know it worked. All right, here we go with our next example, and we have the distributive property. what I'd like you to do right now is see if you remember the distributive property. Negative 2 times x and negative 2 times 5, so that gives me negative 2x. And then a negative times a negative is a positive, so this ends up being plus 10. And now I have distributive on the right. 3 times 4 is 12. And 3 times negative 1x is negative 3x. So hopefully you were able to do that correctly. All right, now I have to decide which side I want my variables and which side I want my numbers on. So I'm going to put variables, I don't know, I guess I'll change it up. So let's do variables on the left. Because it doesn't matter where things go, you just have to decide and label. So which piece on this side doesn't belong on the left? Hopefully you're saying the 10 because the 10 is not a variable and only variables belong on the left. So let's minus 10. Now when I subtract it, I'm going to line it up with the 12 because that's what would end up combining with it. So I get negative 2x and then I'll get 2 minus 3x. Okay, now I keep looking. Everything on this side is a variable, so that's fine. But there's a variable over here and that belongs over there. So I'm going to move it by adding 3x. And so I get positive 1x equals 2. Now you could just write x equals 2 because you don't need the 1. If you want to write the 1, that's fine. Let's check it. So pause the video and see if you can check it on your own. When you're ready, play. All right, so here's the check. Hopefully yours looks like mine. And remember, in a check, you're not doing inverses or distributive property, you're just doing regular order of operations. So parentheses comes first, then comes multiplication, and I got 6 on both sides. So I know that my answer of 2 was correct. All right, this is as far as we're going to go in this lesson. I know there is more to your worksheet, but we're going to save that for another day. I want to practice these equations first, and if you have any questions, write them down and ask me when you come to class.